Namaskar students. In this video, we will talk about improper integrals. Let us start with a notation which we have for the definite integrals. Here we are integrating the function fx with respect to x within the limits a and b. Now, if this function fx are integrand, if it is unbounded in this interval, closed interval ab, if we have such case, then we call this integral as improper integral. So this is the one kind of improper integral. The first one which we have discussed here. The first is if we are saying here that f is unbounded. What we mean by unbounded means it will be taking infinite value at some of the point in this closed interval AB. If f is unbounded on the interval which is closed interval AB. And the second thing is that if here the limits of integration which are a and b, they are not finite. If limits of integration, if the limits of integration a or b or both are not finite. So if we have this case, then we call this integral as improper integral. Let us discuss it with the help of some examples. Let us take an example. Suppose we have this integral. We are integrating 1 by x with respect to x within the limits 0 to 1. Now, if we check for this 1 by x at this point 0, here the domain of integration is this closed interval 0, 1. But this function 1 upon x, it will be unbounded at this point 0. At x equal to 0, this 1 upon x will become infinity. So this 1 upon x is unbounded in this interval, which is closed interval 0, 1. So this is an improper integral. Let us consider one more example. We are now integrating 1 divided by 1 plus x square with respect to x within the limits 0 to infinity. Now, here, if we see this one, this case, the limits of integration. The limits of integration are not finite. This lower limit is finite, it's 0, but the upper limit is not finite, it is infinity. So this is again an example of improper integral. Now, when we talk about improper integrals, then when we solve or evaluate these improper integrals, they may exist or they may not exist. So if we can solve the improper integral, we can evaluate that improper integral, we call that particular integral as convergent. But if we are not able to solve any improper integral, we call that the given improper integral is not convergent. We have discussed gamma function, and if you remember the limits of gamma function, they are from 0 to infinity. So gamma function is also an improper integral which is convergent for some values and which doesn't exist for the negative integers. Now we have two kinds of improper integral depending on the case, whether the function fx, whether the integrand is unbounded, and the second thing, whether the limits which we are having in the integral, they are infinite. So depending on these two bases, we have two kinds of improper integral. So let us discuss them one by one. So the first one is, improper integral of first kind. So when we call that the improper integral is of first kind, if it is in any of these three forms, which I am writing here, the first one, this integral, this is an improper integral of first kind. Why it is an improper integral here? Because the upper limit is not finite, it is infinity. The second type of this integral, improper integral, if you're saying that the lower limit is not finite, it is minus infinity to b. And third possibility which we have is when we have lower limit as minus infinity, upper limit as infinity, and the integrate is fx dx. So we have these three cases here. In the first case, the upper limit is not finite, it is infinity. In the second case, the lower limit is not finite, it is minus infinity. And in this third case, both upper and lower limits, they are not finite, they are minus infinity and infinity. So such integrals where the limits of integration are not finite, they are improper integral of first kind. Now, how we can solve these improper integrals of first kind, how we can check whether they exist, whether they are convergent or not. So let us discuss the first case. If we have to check for this one, this integral, which is within the limits a to infinity, that this particular improper integral, it is convergent or not, then what we will be doing, we will be evaluating in this case, we will be evaluating first of all this integral, lower limit we will keep here a, and we will consider here upper limit as c, and we will be evaluating this definite integral. And after evaluating this definite integral, we will be finding this limit c tending to infinity of this above mentioned integral. And if this limit exists, in that case, we will be saying that this particular improper integral is convergent in nature. So if this limit exists, then this integral will be convergent, and that limit which we will be getting here, that will be the value of this improper integral. But if in case this limit does not exist, then in that case, this improper integral does not exist and it is not convergent. Now, if I talk about the second one, the second case, this one, in the second case, which integral we will be considering? Here the integral which we will be considering is, now we will keep upper limit as b, but we will take here some real number a, and a as lower limit, and the upper limit will be b, and we will be evaluating this integral. After evaluating this integral, we will be finding the limit, and now which limit will be tending to minus infinity, because here what we have minus infinity. So we will be taking here limit that this a is tending to minus infinity. So what we will be doing, we will be evaluating this limit by considering that the lower limit a is tending to minus infinity. If this limit exists, in that case, we will be saying that the given integral is convergent. If this limit exists, it has having some finite value, then this improper integral will exist. And suppose if we are saying that this is equal to say L, then the value of this improper integral will be L. Similarly here, if I am saying that this limit is coming as say some L1, then and L1 is finite, then this improper integral will be equal to L1. Here these L and L1 are finite. And if these L and L1 are not finite, they are coming as plus infinity or minus infinity. In that case, these improper integrals of first kind, they will not exist, they will not be convergent. Now, what we will be doing is this third case. In this third case, both lower and upper limit are infinity. So in this case, we will be writing this integral, we will be considering an integral, we will considering two integrals. We will be writing this integral in terms of two integrals with the help of some real number, say a. So I can write down this as minus infinity to a is some real number, fx dx, and then another integral will be having limits from a to infinity fx dx. And we will be checking for both of these integrals. For this first integral, we will be using this approach which we have discussed here in this second case. And for this second integral, we will be using this approach, this first one. And if both of these integral exist and we are getting these limits as finite, then the sum will exist, the sum will be finite, and this improper integral will also exist. So this will be the approach for this third case. We will be writing it as sum of two integrals. Both of these integrals are improper integrals. We will be checking them in the way we have done for these two cases, previous two cases, and we will be making here conclusion whether this improper integral is convergent or not. Now, let us take the second kind of improper integral. We have improper integral of second kind if the function f is unbounded in the interval of integration, in the closed interval ab in which we are integrating. If the function is unbounded, as we have taken example also, this example, this first one, this is the improper integral of second kind. This is of second kind. Second kind, because here this integrand 1 upon x is unbounded in this closed interval 0b, 0, 1. And this integral is improper integral of first kind. And if we see here the upper limit is infinity. We can check here, we have just discussed that it is of this first type, a to infinity. So improper integral of second kind. So suppose we have this integral. Now we are saying that we have improper integral of second kind if fx is unbounded in the closed interval ab. Now we have various possibilities. This fx it can be unbounded at the point a. It can be unbounded at the point b only. Or the third possibility is that fx is unbounded at some point c, which is lying between a and b. So let us consider all these three cases one by one. So first case, if we are saying that f if f is unbounded at a. Now, in this case, how we will be checking whether this improper integral exists or not. And if it exists, then what is its value? So here, we will be considering the integral by shifting this a plus epsilon. And there will be no change in the upper limit. Upper limit will be same, b. Integrand is fx dx. See, we have this interval ab. We are integrating this function fx in this closed interval ab. Since fx is unbounded at this point a, so within this interval, we are shifting little bit, we are shifting slightly, we are shifting here. And we here, what is this epsilon? This epsilon is positive, and we are moving somewhere in this interval AB with the help of this epsilon, and we have here the new limits a plus epsilon to b. Why not? We are not considering a because here the function is unbounded at this point a. So we will be evaluating this integral, and since we are moving slightly, we are moving very near, we are very near to a. This distance is negligible. So after evaluating this integral, we will be finding this limit that this epsilon is tending to 0. And if this limit exists, if it is coming as finite number, say that finite value is L. So if we are getting finite value, in that case, this improper integral will be convergent and it will converge to L. Now, if we have the case that this if f is unbounded at the end point, which is b. Now, what we have to do? We have to remain within this interval. Now, the new integral which we will be considering here, what should be its limit? Lower limit, we don't have problem with a because the function is unbounded at b now. So the lower limit will be the same a. But since function is unbounded at this b, we will be taking here the upper limit as b minus epsilon. We will not be taking it as b plus epsilon, because if we are taking it as b plus epsilon, we will be out of this interval, closed interval AB. So we will be taking here the limits from A to B minus epsilon. So we will be evaluating this integral. The lower limit will be same A. Upper limit will become B minus epsilon fx dx. And we will be considering this, after evaluating this integral, we will be considering the limit. We are taking here that this epsilon is tending to 0. If this limit exists and say it is L, then this improper integral of second kind will be convergent. It will be defined. It will exist. Now, if we have the third case, we are saying that at some point, say C, which is within this closed interval AB, the function is unbounded. So this is the third case. If f is unbounded at C, where the C is lying between A and B. So what we will be doing here, we will be splitting this improper integral into two parts. with the help of this point C, A to C, and the second integral will be having limits from C to B fx dx. Now this first one here, now this function in this integral, this first integral, this function fx is unbounded at this point C. So this is the same case which we have discussed, this one, the second case. So we will be writing it in the form of this integral. We will be evaluating limit. If this limit will exist, then this first integral will exist. It will be convergent. Now, if I talk about the second integral which we have here, here the limits are from C to B and the function f is unbounded at the point which is C. And if I compare it with these two cases which we have discussed, it is of this one, this first case where the function was unbounded at A. So for this second integral, we will be using this first approach. We will be evaluating this integral. We will be considering this limit, and if we get the limit as some finite number, if both of these limits we are getting and they are finite, in this case this improper integral will exist. If any of these two integrals, improper integrals, they are not defined, they are not converging, then this improper integral will not converge. So in this way, we will be considering these integrals, we will be evaluating these limits, and we will be checking whether the given improper integral, the improper integral which is given to us in the problem, it converges or not converges. So we will be considering these integrals first, then we will be in next step after finding these integrals, we will be considering the limits. If we are getting limits as finite number, if the limit exists, then these integrals will be convergent. Thank you. In the next video, we will be taking some problems of improper integral.